Here we are, it's part 4 now, on page 962 of the urinary system. And we have a picture here that's showing us what's going on with regard to the glomerulus and the nearby tissue structures of the glomerulus, and they magnify it for us right here. Here's the glomerulus. We see red blood cells in here and blood. We also should be sensing that there is a group of openings here called fenestrations that allows sort of like the liquid portion of the blood to sprinkle out. Okay, here we have the afferent arteriole. Here we have the efferent arteriole. The afferent arteriole is unique in that it contains, the wall contains these granular cells here, referred to as granular cells. What's inside the granules of the granular cells is renin. Should the blood pressure get too low, then renin will be released. Normally we don't think in modern times, in the 21st century, oh my goodness, the blood pressure is too low. This is not a common finding. The reason it's not a common finding is that people lead stressful lives. And we buy our food from Safeway, and there's a lot of processed foods. We also buy our fast foods. We buy our potato chips and other types of crispy things. And ultimately, we end up with high blood pressure, or certainly not low blood pressure. So historically, the kidney is living about maybe 30 to 50,000 years ago. It has not evolved. It has not changed. No pressure yet. That could change with time and ever more food from Safeway, but at the moment we still have kidneys that think that the prime, directive is to avoid low blood pressure because historically it was hard to find clean water and food and that sort of thing. It was also very hard to find salt. So as long as you have enough pressure, that is to say you're drinking plenty of water, so you have a good blood volume, and you're having food that contains sodium, that means that you have good blood pressure, good sodium, and the filtration occurs. And part of what is going on in the filtration, especially in Henle's loop, is that sodium is being pumped out in order to create electrolyte tonicity so that you can get the water to come out of the nephron. So, and back into the blood. You want to spare your water. After all, you're going through 40 or more dialyses per day, and that's a lot of times to spill your blood. You want to get it back, right? So you need to maintain some pressure here. You also need to have lots of sodium so that you have a source of tonicity. So there's a very deep story that happens here, and I'll tell it slowly. The deep story is right here. We have the very last little bit of loop of Henle before it goes to become the distal convoluted tubule. Here we have the beginning of the proximal convoluted tubule. So this is the first chance we get over here to reuptake all of the essential nutrients that have spilled out. We're going to let go of things that are not necessary. Anything that's not necessary or even toxic is going to be left to become urine. But things that we would like to be keeping, the vitamins and the essential nutrients like glucose, water, and other items of interest, we're going to be taking back up. Okay, then we're going to be also collecting a lot of sodium in order to create tonicity, and this is the end of it. This last bit here is the last of the ascending loop of Henle where we've been pumping sodium, assuming that there's sodium to still be pumped. That is to say, you had a diet that was seasoned with some salt. Here we have these very tall cells, and they're very prolific at pumping not only sodium, but also because they're pumping, it's active transport, they're using ATP. So I've listed here ATP. Literally, this is a song that these cells, let's name the cells, They're called the macula densa cells. And again, I've expressed here the idea that macula densa cells are literally singing ATP. So they're pumping sodium and they're expressing ATP as part of the process, sort of whistling while we work, as it were. And who is listening to this song are the granular cells. So the granular cells, as long as there's ATP, they are calmed. And I want you to remember that forever and ever. That the ATP that is being produced by the macula densa cells that are pumping sodium, they are using ATP to such a large degree that they're actually creating the signal of ATP. There's excess, and some of that excess is coming over here to calm. And what sort of calm do these cells need? Basically, these cells are calm if there's enough pressure. There's two ways that they sense a decrease in pressure. One way is that the pressure is so low and it took so long to pump the sodium. There's no sodium by the time it gets to the macula densa cells. And so the macula densa cells have no sodium to pump, and they're not expressing ATP. And the granular cells are a little disappointed. And they sense that something is amiss, and they release renin to activate angiotensin to create greater peripheral resistance and greater blood pressure. Another option here is that there is simply not very much pressure to hold open this artery, and that's called the myogenic mechanism. And so if you push against the artery pushes back and protects the downstream capillaries. So a person could have high blood pressure, and it's not a problem because the afferent arteriole can control the pressure if it's too high. What it can't control is if the pressure is too low, and there's not enough push here to actually push the fluid portion of the blood out into the nephron. We call that renal failure. So if there's not very much push against the wall, again, these cells will sense it and they'll release renin to activate angiotensinogen to angiotensin and create peripheral resistance. So the story is not over yet. There is still more going on here. These little cells in here that are historically called by another name Lacis cells, LACIS, they're currently called extra glomerular mesangial cells, or just mesangial cells. They have some special roles to play, not the least of which is that it's possible to sense through this area that there is a lack of oxygen. If you begin to live at a higher altitude, or you begin a sport or possibly a job in which you're called upon to be physically active, you might need to have a higher hematocrit, at which point EPO, erythropoietin, will go out, will activate the bone marrow, and you'll have erythropoiesis. Okay, so you'll get more red blood cells. Another detail here is that this is active in activating vitamin D. So vitamin D gets to its active form here. There's yet something else that we learn, which is parathyroid hormone is acting to, further the possibility of activating vitamin D. So parathyroid hormone actually stimulates the kidney even more so to activate the vitamin D when we need to have more calcium, because vitamin D is required at the gut level to transport more calcium across the membranes. Okay, so now we're over here at this little thought process here. Here we have filtration happening, number one. We have the word filtration. Here we have reabsorption, which is we get back all of our favorite nutrients, and what's left over becomes urine. And so all of our favorite essential nutrients will get back. And then we're going to secrete, actively transport things that we don't want and we can't get rid of fast enough with filtration. Who are they? That's hydrogen ion if you have acidic blood, antibiotics or other toxins, and potassium. So we'll pick up that again in the next episode.